Okay, so this problem was pretty easy. Just plug in your calculator, 0.356, I don't think I'm gonna miss that one. Okay, part B, yeah, I think what happened here, I think some people took too long on this because there were some, I don't know if it was in this room, but I remember in G period, like there were a couple people taking a half hour on part one, and that obviously doesn't help to spend half an hour on some of these kind of problems. So we do have to talk about efficiency. I think that's one thing that might help. If you did take even 20 minutes, that still kind of burned down time a little bit. A problem like the part B should take about 5 minutes, I'd say. I mean, if you think about the process, you want to set equal to -1.2, divide 2, take the inverse sign, you get the answer. This is the part I think maybe we need to spend more time talking about how to actually do. I think this is the part where you guys got stuck. And I could tell that was an issue when we were covering this. I mean, so reference angles, so we really want to beat that drum loudly, like that's a reference angle, right? But it's technically a positive 0.6435. Since signs be negative in Q3 and Q4, I did pi plus that number, and I did 2 pi minus that number. Of course, I changed the number to positive 0.6435. So once I have that and add the 2 pi k, then it's just solving for x. Like multiplying by 2, adding pi, you're good, you're done. But I think this connection, I think was slower for you guys. And that's okay. You guys are still making sense of it. But I think that's what kind of slowed you guys down a little bit and kind of frustrated you guys. So that's something we need to spend more time talking about how to work through that. Of course, once you go in Desmos, or actually, yeah, you guys, I did let you guys use Desmos. You guys are fine. Two was great. I don't think two was a problem. Actually, I thought two was a fun problem. That went well. Didn't really see any major issues there. If you miss any points, just talk to me. Here, you might miss a point here or there. I don't think this was a major issue either. What I was looking for is like make sure you had two cycles, make sure you had the asymptotes the right place. The key points would be the point in the middle and then the stretches, which are called like the quarter points, like between the first asymptote and the middle point, and between the middle point and the second asymptote. So trying to show that stretch as well. I was a stickler if you didn't say K is any integer. You do have to be precise about that. Again, it's just training you for AP calculus next year. So it was a half point, not a big deal, but some of you guys did lose half points here and there because of that. So make sure you do state that. You have to be very precise with your language and clear with what you're saying. 4B, I think some of you guys are still having a little bit of issues with the default ranges. I thought A was fine. I didn't think I was some of you might have missed it. Just talk to me if you missed it. But part B, -17 pi over 2. If you think about it, that's -16 pi over 2 minus pi over 2, right? Because -16 pi over 2 is -8 pi. So if you do -8 pi, you go around 4 times, but clockwise. And if you go negative pi over 2, you land in the negative y-axis. Hence, the y-coordinate there is -1. Inverse tan -1, of course, is negative pi over 4. So you guys say negative pi over 4. Some of you guys said 7 pi over 4, but that wouldn't be in the default range, right? So you want to be mindful about that. Some of you guys said 3 pi over 4, but again, it's not in the default range. Even though it's true, right? For 5, yeah, there were some issues here too. This was without a calculator. Subtract the 2, divide the 4. Inverse secant, make it inverse cosine. And then think, oh, there's two places that happens. 2 pi over 3, 4 pi over 3, that's where cosine's negative. Then put the plus 2 pi k, and then just solve for x. Multiply 3, add pi. If you do that, you should get each of those answers. And then, of course, figure out which one's the third negative answer based upon that. So you could do k is -1, k is -2. You should land -7 pi for that one. 6 was an issue as well, I think, for some of you. You had to use the half angle formula. There's no way you could add or subtract two angles from the unit circle to get that because the denominator is 8. So you have to use the half angle formula. And half 5 pi over 4 is 5 pi over 8. Once you do that, great. That's what you're doing. You plug it in. Wait, did I make a mistake with this one? No, I'm okay still. Oh, okay. I did make a slight error in my answer key, but I'm still okay. This should have been -5 pi over 4, my apologies. But cosine of -5 pi over 4 still is in the second quadrant, right? So it's still negative. So I'm okay. I'm still okay. I should have made that negative. Cosine 5 pi over 4 is the third quadrant, but that's still okay also. So anyhow, my mistake, but you should still get this regardless. You get that, then you get this, and then you have to clean it up. And then clean it up, make the denominators the same, root 4 is 2. And why the negative on the outside? Why is it negative on the outside? Yeah, because -5 pi rate is the third quadrant, and sine's negative in the third quadrant. So that's what you have to make it negative. Right. So again, it's those kind of I think it's that I'm stretching you guys a little more with like, oh, default range is a little abstract. The thinking like where we do inverse sine, like what quadrants you have to be in, like number one here, right? Like, that's the thinking that you know, it's good. You guys are getting trained in it. Don't worry if you stumbled. It's okay. I know you guys are working hard. It's not a lack of effort. If it was lack of effort, I would have been guns a-blazing. I would have ripped into you guys right when you guys walked through the door. I rarely do that. I don't like that because I get really anxious like that. I know you guys are working hard. Just we'll keep working at it. It's just a skill we need to develop to stretch our thinking with the abstract reasoning here, right? For number 7, you want to draw a triangle. And remember, it's arctan, so it's opposite over adjacent. X is already negative. It's already implied that X is negative because they already told that. So you don't have to do anything special, right? It's cool. So you don't have to write negative. If you actually write negative 2x, that'd be counterproductive, right? Because then you're saying it's positive. We got to keep this negative because X is already negative as it is. Do Pythagorean theorem, you get that. You want the cosecant, which is hypotenuse over opposite. So hypotenuse over opposite, that's what's right. That's 7. For 8, yeah, 8 was interesting too. And this is where I feel, okay, I probably should have taken a problem offer too. I probably should have done that. And actually, let me evaluate G periods, and I might do a sliding scale, meaning those on the lower end will get more of a boost, and those at higher end won't get, but they'll still be equitable in the sense that like say someone got an 80. And someone got 83, but the one that got 8 got like an 8% bump. Someone that 83 got a 3% bump. Like I wouldn't do that. Like I would make sure it's equitable. So I'll think of something that kind of helps the grades out. I'll take a look when I put them in. Because I do admit that something like this require a little more time. And if I were to remove a problem, maybe I'd remove like 6 or 7 perhaps. So maybe give back 6 points. I'll think about it. But it'll be actually 7.5 percentage points, right? Because I have 80 points. And by the way, my tests are all weighted out of 100. Even if I have 80 points, it has the same weight as all the other tests. The previous test was 100 points because it just came out that way. But all my tests have the same weight, just so you know. I do weigh them all the same. Okay, for 8, I think you guys were cool drawing the triangles. I think where you guys ran into a problem, and this is maybe you guys were rushed for time or getting nervous. That's just probably what happened. So you guys were putting these fractions into the letter A. Remember, the letter A is an angle, right? You don't substitute for A, you substitute for the trig expression, right? The entire trig expression equals that fraction. So cosine B is 2/5. 2 cosine squared A, whatever that is, you'll work that out. Wait, did I just take that one? Well, no, I didn't. I get it. I'll get it. You get it. This is on Friday night after the homecoming game. I was like, okay, make sure that's right. Yeah, that's right. 5/3 minus 1. Yeah, I took my calculator. I think that's right. Yeah, and then this one here, but you gotta be careful because there's a lot of different things you're plugging in for. Like you really do need to do substitutions. So you don't know what 2A is. And then you clean it up and get that. And lastly, 9. I thought this was actually a good, I probably took a little longer. Some people actually were able to short circuit this more quickly, which is good. They were get done quickly, but yeah, I don't think this was a major issue. If it was, just talk to me. I would say 8, probably 6, 7, probably 5, 4B, and 1B. Those were the ones that gave you guys trouble. Um, so in terms of retakes, we're not doing retakes for all the levels of pre-calculus. So at level pre-cal, pre-cal B, pre-cal BC. So I have to be consistent with that. But what I might wind up doing to help you guys out is like maybe I'll try to do quizzes that are intended to help you. I don't know, or we'll think of something to kind of help you if but the curve I think should help. Definitely I'll be open to doing a curve because I think that would be fair because the test was long. So anyhow, that's the test. New stuff. Let's talk about new stuff. So we're on a new unit. The plan for this new unit is get it done in about 4 days. We could do it in 4 days and have a day of review. So we have 2 more days this week. 2 more days this week. We have 3 days next week. The week after is the week of parent-teacher conferences. Probably I would do it near the tail end of that week or maybe the week after. I'm not sure yet. I have to look at the calendar because we can't lose time. Um, but I also know you guys are doing the PSAT. Those who are juniors are probably doing that. No, I don't think so. For juniors, it might be. Sophomores, not. Yeah. And I think you do it on that Wednesday, I think. I don't know. I have to look. Um, so I'll try to be mindful of the schedule, but we do expect another test around the middle of October. We'll have another test, and it'll be a short test. Anyhow, so we're going to talk about something called conic sections. So that's the new unit. It's called conic sections, and I should have been better prepared, but I'm going to just do a quick Google image. There we go. Yeah, still in that count. Ah, perfect. That's exactly what I wanted. Look at that. Okay, got lucky there. All right, that's a great image. Okay, so what we're working on this unit, usually we taught algebra 2 trig honors, so now we've reserved calculus. The double nap cone is basically two cones that are facing like this. Actually, sometimes I would go to Michael's and get like styrofoam cones, and I would bring a very sharp knife from my kitchen and cut the cones. It gets a little scary because the knife is very sharp. But I would cut the cones in certain areas, and then you see the cross section, and the cross section would be a certain shape. For example, if I took a knife and cut this cone parallel to this base or that base, the cross section would be a circle. If I took a knife and cut it at an angle like this, it would be an oval, like an ellipse. If I cut off a corner here like this, it actually forms a problem, believe it or not. That's a problem. If I cut it lengthwise like this, you have two problems go side like back to back. We call that hyperbola. So these are the shapes we're going to be dealing with. We're going to do a more algebraic rectangular coordinate kind of way of approaching this where, okay, here's the equation. Circle by was x squared plus y squared equals r squared. We'll talk about that. I'll show you the derivations for these as well. But then we're going to incorporate trig into this in the final day of this unit. We're going to see how does trig play a role with this, because trig does play a role with this. And that'll be a nice opening to polar coordinates, which we'll do in the second half of October and first half of November. So, but for now, we're just going to kind of keep things more algebraic. So there's a lot of algebra we're going to do here. So we'll talk about circles today and parabolas. Circles you guys should be very comfortable with. And it's actually pretty easy. So let's do stuff that you guys should be comfortable with. So this is kind of a review of geometry honors for those who are, or regular geo for those who are juniors. You did geo here. For those who are sophomores, you probably did geo or some sort of geo in middle school. So let's just do some problems, and we'll talk about the equation of circle and why the equation of circle is the equation of circle. It's right in front of you. Oh. You probably feel up late, that's fine. Sorry. That's all right. Are we keeping it fast? Oh, shoot, we need fast. Okay, that's what I did. I know that, right? I did in fact, yes. By Friday, you should get it back.
It's the square root of y's. Why the plus is here?
And let me just pause this for a moment and the updated grade. That's right. Well, now we're recording, whatever. I guess keep going here. Right. Everyone's here today. Part B. Actually, why don't you guys do B, C, D on your own? I think you guys can handle it. Now you guys should be able to tell what's the center and the radius. For D, by the way, divide by 15. Right? For D, divide by 15. So
what's a rough value of root 5?
2.2, 2.3. Yeah.
You remember that? Yes. Oh, yeah.
Okay. Good. Yeah.
Yeah.
Was I too fast? Or you guys were faster than me?
No.
Okay, good. You're faster than me. Good. All right. Writing the equation should be pretty straightforward as well. Seriously, just do Pythagorean theorem to get the radius. You're going from -2 to 3, that's 5. 5 -1, that's 6. That's root 61. Equation, easy peasy. X minus 3 squared, y plus 1 squared equals 61. So hopefully that's pretty straightforward. A test won't be that easy, just so you know. But we just got to do the foundation stuff first. And what time do we get out today? At 10:25. Cool. That's what we'll do. Okay. Okay, let's keep moving. Next up, you're asked to graph the circle with those endpoints, find the radius, find the center, write the equation, and then find the equation line tangent to this. Okay. So how have you guys? Yeah, you guys can handle this. So let me have you guys do 4 A, B, C, D on your own. Did you guys do this in Geo honors? Because it's kind of stuff. Kind of. You did? Okay. To find a midpoint, how can you do that more intuitively instead of like using a formula? If you just think about it, you're averaging what? X is the Y exactly, which would be -1 comma -1, actually. You get 5 for the radius. Yeah, it's lovely when it happens. And then to write the equation online, I did a crappy job drawing this. And here's why I know I did a crappy job. What's true between a tangent line and the radius of a circle? Good. The tangent is always perpendicular to the tangent. Good.
I have a question about C. What does it mean when it says contains this diameter?
Oh, just
If I just saying with those points.
yeah, I got confused by the question too. You're not putting the diameter into the equation. Just draw an equation for the circle.
Oh,
Or
okay.
write an equation for the circle. That's all.
Okay.
Yeah. Yeah, I know it's a little confusing. But yeah, I didn't that my radius does not look perpendicular to that blue line. Just go with it though. It should be perpendicular. So you want to find the slope of that radius. What's my slope of the radius? Up 3/4. So what's going to be the slope of my tangent line? -4/3. And I much prefer that you just write it in point slope form. And you know it contains a 0.32. So you y minus 2 equals -4/3 x minus 3.
Wait, so you want, if I'm there, you want to like the, equation of the line in point slope?
It's easier. Yeah.
Well,
I just wrote right here.
I mean, I'm more familiar with like,
Slope intercept.
why get marked off.
No, but what I will say is that if you make a mistake, you'd hurt yourself. Because you have to do it's more work for you.
Okay.
You can. On the AP exam, that is preferred form is point slope.
Okay.
Actually, I will say when we get to a more advanced shape, the hyperbolas, you're gonna want to go with because there'll be asymptotes, it'll be kind of weird. You're gonna drive yourself nuts if you try doing and slope intercept. So it's in your best interest to use point slope if you can. Yeah. Does that make sense? We're good? Okay, let's keep moving. Couple more questions on circles. Good, we will. All right. I'll try. All right. This next one's pretty straightforward as well. Your center is at 3, -4. Your radius is 5. So great. 3, -4. Radius is 5, so you gotta go 5. Shoot. Here we go. 5 away. And then x equals 6. Change colors. And find the coordinates where they intersect. Well, that's easy. Just plug in 6 for x. You solve for y, of course. So y plus 4 squared equals 16. Y plus 4 equals plus minus 4. So -4 plus 4, -4 minus 4. So I didn't, again, draw the greatest, but 6, 0, and of course 6, -8. Okay, the last one. You're asked to rewrite it in standard form. So standard form we already derived, right? X minus 8 squared plus y minus k squared equals r squared. That was the standard form. We derived that already with the standard is h comma k, radius being r. How would I rearrange that equation that you see in number 6 to make it look like that? What would I have to do? Good. You got to complete the square. Yep. You guys remember doing that in Mr. Mann's class?
No.
Yeah, completing the square is actually a big deal in this unit. So becomes very algebraic. But it's a very formulaic process. It does get more challenging when the coefficients of x squared and y squared are not 1. We'll handle that when we get to the more complex shapes later in this unit. But for now, this is going to be pretty straightforward. I would actually separate out the x's and y's like this. Okay, how do you complete square? You guys remember? Yeah, half of the linear coefficient and then square it. So you're going to add 1, but you have to add 1 over here. And here, what's half of -4 than squared? So add 4 to both sides. By doing that, you can now rewrite it like this. There you go.
Can you say again how we got 1 and 4? Like,
Oh, you take half of this.
And square.
okay,
Yeah, that's all I did.
But remember, whatever you add to one side, you gotta add to the other side to keep it balanced. Because we need to have that balance, right? But yeah. And then that's it. Yeah, there you go. So your center is at -1, 2, and your radius is root 57, some weird number. So okay, so that covers circles. All makes sense? Okay. All right. Let's now talk about parabolas. And I think we could try to get all this done before class gets out. And you have homework on circles and parabolas. But ellipses and hyperbolas, I'm going to dedicate just a day to each because those are a little more challenging. Before I do this, you guys could just relax a little bit. Let me show you the derivation of a parabola. So if you guys are curious why a quadratic equation, like y sum of x squared, is associated with parabolas, here's the real reason why. It probably never been explained to you until now. So how did, like, why is that true? Like, why is y equal x squared look like a parabola? How is that connected? These derivations I will, oh, wait. It's going to be my algebra 2 honors folder. Hold on a sec. There we go. Circle we already talked about. So, but I'll post these to the school just so you have access to these. You won't be asked to do this on a test. Just good to know. And if you can read my chicken scratch here or my handwriting. So derivation of standard equation of parabola with vertex at 0, 0. So I put it at 0, 0 to keep things simple and had it opening up. What is the definition of a parabola? A parabola is defined as a set of all points equidistant from a fixed point and a fixed line. So the fixed point we call the focus, the fixed line we call the directrix. I know, kind of weird names. So capital F is the focus. That's a point out fixed on the y-axis. We call it 0, b. The directrix is a fixed line, while below the y-axis, we'll call it y equals negative. And the distance. So both of these are the same distance from the vertex. This point is p away units, and this use p. I don't know why we use p. Just go with it. And you have x, y random point on the parabola. Now, what this is telling me is that any point on the parabola, if I draw the distance from this point to that point, and this point to that line, those two segments will always be the same. So if this parabola extended up over here, like right where my finger's pointing, from here to there and here to there, those will be the same segments, same length. That's the definition of a parabola. Does that make sense so far? What I'm talking about? You guys see what I'm trying to do? So again, you have a random point, I'll put on the y-axis. You have a random line, I'll put it horizontal. And when I say random lines, it's usually horizontal or vertical. That usually it is always going to be. And if you pick any point on the parabola and draw a segment from here to the focus or here to the directrix, those two segments will always have the same length. So D1 must equal D2. I'll call this D1, I'll call this D2 must always equal each other. So what does this mean? This means I'm going to use a distance formula, set them equal to each other, and then do some algebra. Things will shake out very nicely where I'll get y equals x squared. You will. And that's how it comes about. So if I look at D1, that's just from x comma y to 0 comma p. I call it 0 comma p. So you get that crazy radical, root x squared plus y minus p squared. This will all be in Schoology. If I find this segment, it's just a straight shot down. Looks like it's p minus negative p or 2p. Or sorry, I don't know what I'm talking about. I meant y minus negative p. So y plus p. So those have to equal each other. If I set them equal to each other and square both sides and cancel a bunch of terms, you wind up stumbling upon this one. And that's why the parabola takes on something that's quadratic or something that's square. Probably take some time to look at this again, just talk about it later. As first time you see this derivation, it probably helps to actually do it yourself. I probably should have done as an activity. We don't have time for that right now, but that's how it comes, that's how it came about. So that's, and p is just some coefficient for y. Or you can move to the other side, make it 1 over 4p. Some people do that. They like to move the 4p to the side with x squared and make it a fraction, 1 over 4p, x squared equals y. You can do that too. So going back to the notes, let's talk about a parabola. So again, it is a cross section of a double nap cone. If you cut a cone at its corner, the cross section will be a shape of a parabola. Every point on the parabola is equal to a point called the focus and the directrix. We talked about this. So if I draw 0, 2, we'll call it my focus. Y equals -2, we'll call it the directrix. It's not asymptote, mind you. You know, I'm making a dash. So this dot naturally has to be the vertex, right? And it's really hard to tell how you're going to draw it. But here's the thing. This distance here, we call P. And the formula I already showed you guys now. I already showed you the formula. So if P is 2, then what's my equation? X squared equals 8y. It seems kind of weird because we like to isolate y. Actually, I prefer you guys don't. I prefer you write it this way. Just because it just gets really messy with the fractions. So actually, I kind of did part B before I did part A. If I make a quick table, I know 0, 0 is a point on my parabola. Give me some other points that we can plot that would involve integers. What do you think could be some other points on this graph? You could do root 8, 1, but it'd be weird to graph root 8. How about integer values? Well, what if x is 4? Yeah, what if I did 4, 2? Yeah, I could do 4, 2. Bet there has to be symmetry. Yes, good. There has to be symmetry. So let's do 4, 2.
Yeah.
And -4, 2. Now, do you guys see that blue dot? How far is it away from that pink dot? How far is that blue dot from the pink line? Boom, got it. Yes. That's a parabola. It's kind of wide, but who cares? We're doing it accurately. And we have the p-value is 2 here. P being the distance from the vertex of the focus. Can you go?
So do you determine the vertex, like, just like the closest point between the,
Halfway.
halfway?
Halfway between the focus directors, yes, because it has to.
Yeah, like
You
the
mean
most
this, it has to.
direct halfway point.
Correct.
Okay.
Right. You want the straight shot, like not like, oh, from here to here. No, it's gotta be a straight shot down.
Okay.
A perpendicular segment. Correct. That's good, good observation. If I make my P bigger, what do you think's gonna happen if I make my P bigger? Does it get thinner? What do you guys think? It actually will get wider. Yeah, it will get wider because what's gonna happen? Let's say my P is 4, so that's 16. So y would equal 1/16 x squared. That's a very wide parabola because now you're doing a vertical compression, right? I know it's hard to tell right now because 8 next to the y. So if you move it to the other side, we know the coefficient of x squared is a vertical compression. We've seen that in annihilation before. So if we make P larger, actually, it will make the parabola wider. It'll make it wider. If you want to make it skinnier, you make your P smaller, just so you know. Okay, let's keep going here. And I'll do this with you because this is, I know it's all very new stuff. -2 comma 0. It's my focus. My direction is x equals 2. Here's my vertex. Now, and my p-value is still 2. But it's kind of weird. And I haven't explained this to you guys yet. So x squared equals 4py is for a vertical parabola, because we saw that earlier. So we want to take a stab as what would happen for a horizontal parabola. Yeah, it's the inverse. Yeah, it's the inverse, as it should be, because it's a reflection about y equals x. Because if you had this here, and you drew a sideways parabola, those are inverses of each other, just so you know. So yeah, so that's going to be for a horizontal parabola. But because going to the left, not to the right, what are you guys going to say is going to happen here? Yeah, you can make it negative, exactly. Because you want to go to the left. You want negative x coordinates. So if I make a table, I have 0, comma 0. And if I plug in -2 for x, what's y going to be? 4 or -4. So now there's two outputs. Hence, it would not be a function. It would fail the definition of a function. These are not functions, by the way. They may not be. That makes sense. Yep, there we go. Looks good.
This thing is always just 4py, or is that just
Yeah, correct. Yep,
for all problems?
yep,
No matter what.
yep, yep. Yeah, that is because when we go through the derivation, it just kind of comes out because we're following the definition of a problem. But yeah, so this is truly the derivation of a quadratic function if you think about it. Like we just tug out to, hey, here's y equals x squared. It looks like this. This is really why it's happening. You're getting more of the truth now. Laura, go ahead, and then I'll go to Kaden. Oh, well, from a cone, it's just more than just a slice. You slice a cone a certain way, it's just cross section. That's all. It has nothing to do with the algebra going on here. The cone is just more visual. That's all. Yeah. But the definition of parabola involves that line because we have to be, um, equidistant from the fixed line, the fixed point. I mean, yeah, is there a line on the cone? If you want, I guess you could draw, but that's if you're so the cone thing is more giving a solid geometry perspective, that like a visual, a 3D perspective. This is the coordinate geometry perspective, and that's the approach I'm taking with all the problems you're doing. You don't do anything from a algebraic perspective with this solid geometry. You just don't. Just more just to understand why it's called conic sections. That's it, because it comes from a cone. So just to summarize what's happening here, these are the two forms where p is the distance from the focus to the vertex, and also the distance from the directrix to the vertex. So orientation, hold on, Caden. You got vertical orientation or horizontal orientation. And to keep things simple for today, I'm not going to move the vertex away from the origin today. I will later in the unit. So if it's vertical, it would be x squared equals 4py. I'm just going to the board because I can't.
X squared equals 4py. Or y squared equals 4px. Get a better market too. Axis symmetry is going to be the y-axis, so x equals 0. Here it's x-axis, y equals 0. The directrix, so if you think about it's something like this here, it'll be y equals negative p, and that'll be 0 comma p, and it's all the way around here, p comma 0, and x equals negative.
That's the generalization. Okay, what's your question?
Is there a way to draw a parabola without being given the focus or the directrix?
Well, of course, if you can points or other information, like the vertex or x-intercepts, or I mean, that's all like I guess that did in algebra too.
Yeah.
The reason why we're so intent on doing it this way is because we're going to start connecting this to trigonometry, and we do need to be present to the focus and directrix. It will make sense, and pun intended. Everything will come full circle. Get it? Yeah, good. All right. Okay. It's no dad joke. Okay. I was holding on to that one.
So anyway, 0, 0 is right here. Y equals 3/2 right here. And you're always going away from the directrix. So it's gonna look, I'm just gonna get sloppy about it. I got totally sloppy about it. I know it's gonna look like that. Because it's a vertical orientation, I'll use this. My P is 3/2, but I'm gonna make it negative, because it's going down. So that's gonna be negative 6y. Yeah. Again, I got really sloppy. I should have been better about that. I think there's a point at 6 comma negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. No, it might be okay. 3, 4, 5, 6. Yeah, it might be okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Yeah. Okay.
Okay, that's how you graph it. Questions so far? No? All right. Yeah, I did 6 comma negative 6 and 0 comma and negative 6 comma negative 6. If we don't get to all this, that's okay today. Because I think you guys should be able to handle homework. Let's try one more problem. Let's do this together again. Okay, the vertex is 0 comma 0. This is now horizontal orientation, so horizontal parabola. Now it's a little confusing. We'll say 3x equals y squared. So 4p equals 3. P equals 3/4. Do you guys see how I did that?
Yeah. It's a little onerous board. So you really want to compare it to the standard form. And in all likelihood, I'll give you the formulas because I think I always have for conics. I'm pretty sure I've always given that. So I'll give you those formulas. So you just relate it. Oh, there's one here. Then what you can do is go 3/4 away. And it's going right. Because it's positive for 3. So it's going right. So I want to go 3/4 here and negative 3/4 here. And I don't know, like if you were to plug in you could do like 3 comma 3 is the point, I think. And 3 comma negative 3, I think. I suppose. So
Is the axis symmetry? It's always on the axis, right?
Yeah, it's going to be at the x-axis where y equals 0. Correct. Yeah, I don't want to move it around just yet. I think it's a little too much and class is over in 30 seconds. So I think that's a great place to stop. So homework, you have a homework packet. It's kind of not the best organized. It's a textbook problems. I'll tell you what pages to refer to or problem to do. You're gonna do some circle problems, some problem problems. So I'll put it up in School G later today.
Oh.
Yeah.
I try to see what makes that like a perfect square.
Maybe right.
So 3 times 3 is 9, so that would be a perfect square. So I have 3.
No, I did not.
So what's the plan?
No, office hours, I said they should do that. I didn't tell them during class. I would tell you the same thing in office if you ask. So.
No. What's the goal of me?
But that's when it's x squared.
Yes.
Yes.
So.
It's all-